A very good morning. Um, I can see almost half of the class right now. Can anybody quickly message in the group to ask people to join? Because today we starting with a project, and the thing is, if they miss out the initial part, they will not understand anything.
Hi, Shivank.
He has to be.
I was thinking I could ask just 1 minute. Sorry, having some audio problem with the laptop. Can you hear me fine? Hello?
Yes, I can hear you.
Okay. I was getting one error last night when I was trying to do that assignment. Just wanted to walk you through that by the time full class is here, right? So first error while I was trying to create the partition was dynamic partition strict mode requires at least one static partition column. To turn this off, set that partition mode is good non-strict.
Maybe your audio is like a little bit of echo or something is there. Not very clear. Is guys, can you confirm? Is it only to me or to everyone?
No, it's unclear to me also. A little.
Yeah, we can't hear you, so be very well.
Okay, I just pinged the error in the chat window.
The error is shouting. So we have to set this and try that again. It should work. So just make the partition mode as non-strict. Otherwise, at the sub-partition level, you cannot create the dynamic partition. If you remember, that's what I explained you also, right? No, it should work with that. Maybe you sign out of your machine. Sometime maybe it's not able to take up the setting. And again, retry that. It will work. No, this error is not clear. It is saying that while parsing the statement, it looks like some syntax error you have written there.
So doesn't look like syntactical error because the query was running 2 minutes and then I got this error.
Send your query maybe to me later on.
Sure, sure.
Because without that, I
I'll
cannot
do
say
that.
error
Of course,
message.
yes. I'll send it.
Let me share my screen, guys. We still have some less people, but let's start. Otherwise, it will be too late. Um, Also, anyone who is a senior here, if you can ask the team to maybe join on time, it would really be helpful. Because definitely we need a lot of things to be still covered, and uh, like I said even yesterday, right? I'm only right now able to talk maybe just 5% of the optimizations and all that, not fully completely. And the reason is because of the time constraint. I have to finish this Hadoop section and the NoSQL section in the first 18 hours. And that's a constraint I have because I have to give another 18 hours to Apache Spark and at least 4 hours to Kafka. So that's the reason I also get restricted. So if you can join on time, that will definitely help. So let's start the first thing. Today we will be working on a project. It's going to be sort of a case study, which we will be sort of taking up. I already showed you a data set. You can go and check that again. I gave you a path also, which is, I think under Lakshmi folder. Let me just quickly open that path. So basically from that path, you can go and check that what exactly is the file. That's around 1.9 GB file, which you will be accessing. So what is the problem statement? Let me first explain you the problem statement, and then basically you will be starting on this. Now, one thing I want to make it clear again, just like I said last time also, that whatever projects you will be sort of working on, a lot of times what happens, like you have done a training, but once the training is done, in training you can learn a few items, but every domain is such vast that you will have something new or the other keeps on popping up for you. Now, in terms of concept, there will be nothing coming up. Concept, I have covered everything for you. But in terms of some syntax API, for example, SQL is such a vast thing that I cannot cover all the SQL aspects in the class. But in this project, you will be demanded to know some SQL stuff because you will be writing some SQL things, which definitely I have not covered here, but you have to use it. Just to give an example, you might be knowing about something like rank function. You say something like rank over partition, right? So those sort of things you need to bring up, that how you will be moving across with it. So there will be queries which will come in the later half where you will be required to use all this. So again, like I said, I cannot go on all the SQL things because it's such a vast area, but I already gave you a hint that what you will be looking at lot many sites. Now, what is the problem statement? Though, let me start with an objective. The first objective is the data set which is given to you is going to be a real-time data set. In fact, like I said, let me just quickly open up my second. Okay, so let me just open the lab here quickly. Let's go to the lab. Now from here, I just need to go to my queue login. I don't need to do anything else. Let me go to the files, and inside that I have created a project folder. So this data set, I have also taken it from a public domain. Okay. And this is a real data set. I will show you also from where I have pulled up this data set. And this is, if you look at the size of this data set alone, this is around 1.9 GB. Okay. So this is a real-time data set which is in front of you. And on this, we will be performing some analytics query using Hive. Now, this data set is coming from a New York City. Okay. As you know, it's a big city and it is pretty huge, and there are a lot of problems as well when the city is huge. One of the biggest problem is the parking space, which happens almost in every city, but New York have actually a lot because it's very congested as well. Now, if you look at number of cars what they have, And in terms of the size, what New York is like, the geography is pretty much very less, but the cars are very high. That makes it even more complex. Now, what basically the NYC, which is the New York Police Department, they basically collect a lot of data of the parking tickets. And what they did is they made it public. They made it completely public to everyone. And this is a real data. It is not some made up data. This is a completely given data by the New York Police itself. And on this, they have also done some analysis. In fact, they have hired some data scientists to do analysis. Now we will do the same thing, exactly the same thing for which they have paid and hired those data scientists in the class. So you can see here. So meanwhile, let me open this data set so that I can explain you also what all this data set is. So here you will see multiple things around. Okay, I think it's open. Yeah, you can see here we have this 2014, 2017, 2021, 2016, all the tickets are there. What I did is I took just randomly 1 year, which is 2017. Definitely when you're working on a big data, you should take up for all the years, but I just wanted to kind of show you all this. And here you can see all the data available, like you have parking violations from all this. You can go basically to 2017 from here as well if you want to, but anyway, we are here only. Now here you can see the data. If you want to, you can visualize it. You can even export, and from here I have downloaded this. This is how I downloaded and uploaded this file for you. You can also do the same. You can see people are downloading it for a lot of things. This is a column data set, what they've also given. Like you can see we have some summon number, like when they give a ticket, there is some summon number for it, plate ID, registration state, plate type, issue date, violation code, vehicle body type, and there are multiple more, like vehicle make, issuing agency, street code one, all these things you can see it here, right? So there are some 43 columns what you have around it, and you have 10.8 million rows. This is pretty huge to work on the cloud system. Um, on one node, if you think about it, this is pretty huge number of rows. Now, this is, and even you can see even here, all the details are here with respect to like, what is the type of each, right? So let me give you this thing here. I just gave you this link also, so that if you want, you can even download this data for your purpose later, but I have already uploaded it in your queue, so you can access it from here itself, because it will take time to download, it will take time to upload. So better to use it from this location itself. Now, this is how the data will look like. You can see summon number. This is the plate ID. This is the registration state, which is New York. What is the plate type? What is the issue date of that challan? Because in 2016-17, what's the challan? What is the violation code? So they have some code based on that. Just like you have crime, when some crime happens, there is some the things like 420 section number and all that. Similarly, there's a violation code. Vehicle body type, vehicle make, like Honda car, Toyota car, and so on. Issue agency. Then you have street code 1, street code 2, street code 3. So they have, if you know New York City, right, it's sort of like in a Manhattan sort of way. So that's what it's written, where its challan is kind of taken up. Then you have violation expiry date, violation location, and so many things around that, right? You can actually come to this page and sort of read this data also once. I will give you for this 5 minutes. So for that, don't worry. I will let me first finish explaining you the problem statement, and then we will come back to this. I will give you the time. Now, since we have to do this exercise, what all we will be doing is, let's start with problem statement 1. I will give you multiple problems, and it will start from very basic and become very tough. Okay. So let me give you the problems one by one so that you get an idea that what would be the way we will be proceeding. So first thing, definitely when you're working with this, you have to have some sort of tickets what you have created, right? First, you need to create a table, and then there will be a lot of things you will be performing based on that. Secondly, you will have a lot of things across with it. For example, Your questions will be something like a lot of things will be with respect to, let's say, months and so on. Like in this month, what happened? In this year, what happened? Something like that. There will be a lot of questions around this, like in September, October, November. Like the questions will be also around, like, can you tell me that in this season, how many tickets being taken up? Or when I say basically summers, so you have to go and check in New York when is the summer, not in India. Okay, so a lot of things around that will be also there, which you need to keep in mind. And that's how you will be creating your table. So let me give you the problem statements one by one. First of all, we will examine the data. In this, the first question is find the number of tickets for that particular year. Okay, that's the first question. Then second question is, let me give you some 3 questions to start with. Second question is, find out the total number of states to which cars with ticket belong. The count of states is mandatory here. Okay. Uh, Providing the exact list of states is optional. Okay, that's one thing. Now, third problem is, if you look at the parking tickets, right? For few of the parking tickets, the address is not given to you. So look at this. So like some parking tickets don't have the address on them, which is a cause of concern. Find out number of such tickets which have no address. That is the tickets where one of the street code 1, 2, or 3 is going to be empty. Okay, these are the 3 questions to start with, just to examine the data. We have not started with anything basically very complicated, but it is just to have the simple kickstart of the problem. Now, before we do anything, can you all go, if in case you're not able to copy, like Manju said, you can just say data.city of New York.us. You can come here and then also you can check it out. Should be fine, right? Just go to government, parking violation issue. Then I already showed you how you can come to 2017, come to this page. First, read this data set, create a table out of it. I will give you time for it. Once you create your table, then after that, I will give you the table correct syntax. In case if you have done some mistake, at least you can fix it immediately. And then you start doing your query work for all these 3 problems which I have given to you. Okay, everyone clear on the problem statement? And the data set, either you can download and upload, which will take time. My suggestion is use it in /users/Lakshmi1706/project. All of you start working on it now. In fact, I wrote for each year. Okay, just keep this in mind. Just one point to note here, so that you do not do mistakes while writing your query. Notice that though it's a 2017 data, but still there are some 2016 records. Okay, you have to handle it. And while writing this data also, I mean, when you're writing this query, remember this file also have a header. Okay, so you have to skip it somehow in your query. So come back with the response. I will keep giving you hints so that you don't do mistakes.
Shivang, correct me if I'm wrong. We can access this file only if we log in from this Lakshmi1706 username, right?
Give this location. Just make sure that you do not move this data. Otherwise, from my side also, it should be gone. So make an external table only. Okay. You guys can copy this data, but please don't move this data. If you want, you can copy this data to your SDFS. You can do a get, you can do a put again. Anything is fine. Whoever is able to write that, please let me know. In fact, let me ask you a question in this way. Tell me, I will give you another 2-3 minutes, but tell me, how you will be skipping your header, because in your data file you also have a header which has some column names. How you are planning to skip that out?
Use table properties, skip header count.
Very good. So we will be using a table properties while creating the table, where we can skip the first line of the data. Okay, keep that in mind. So you have to just give a try for next 2-3 minutes, and after that I will give you this particular code for creating the table at this, so that you can spend more time on the major queries of Hive. Okay, so guys, in order to show you how this will look like, first let me quickly show you that how your code should look like for creating. Just need your attention here. So you can see here that you have a create external table, created whatever name you want. You can see that summons number could be huge, so created like a big int. Plate ID could be string, registration state should be string, and you can see all this metadata details already given to you. So there was nothing in it. Then the main thing was row format delimited with comma, new line with a new line part, stored as text file, location whichever you're storing it up. Table properties, make it skip.header line.count is equal to 1, which is going to skip the first line for you. Now, since you guys were complaining that you were not able to copy this, go to your Google Drive, which was given to you. In that, I have created a folder which is named as project. Okay, I have created a folder which is named as project. In that, I have already placed down this code for you so that you can copy paste from that. Okay, just one thing I want to tell you. When I was writing this code in my AWS account, I need that backslash tick, like you can see here. It depends on version to version. If in your cloud it's an older version, then maybe this backslash tick may not work. Then you have to just use a camel case character to combine all this and basically remove. I'm talking about these backslash ticks, which is after, let's say, this house numbers. So this sometimes create problems when you're working on different version of Hive. But since I had written this code on my AWS account, that's the reason even in the location also, though I've removed the complete location, but still this was actually showing the S3 only for the same reason. So just check it out on your Google Drive on the name project. I can send you the direct link for people who can at least copy it. So this is the link. You can click on this, right? This link at least is clickable. So you can click on this link, come to this, and then further to that, you will see a create external table command for you. Okay, I gave you this command because I really don't want you to spend a lot of time into basically writing this code around. I want you to spend time on the major Hive queries. Though this is also important, but still, you can copy paste, have this table, and start working. Make sure that you change the location properly. Okay. All the three questions are in front of you again. And also one more thing, I will do a hard stop at around 8:45 or 8:50 on this project. Whatever we can do, we will do it. After that, maybe I will give you more questions. You can go back and practice it. And maybe once you practice it on Monday or something, I will publish the whole solution for you. Because I've already tested the solution on my S3 account. So I can give you the whole solution, which you can go ahead and sort of execute and check whether you have done it properly or not. Okay? But for now, we will keep a hard stop because we have to also start another topic, which is a NoSQL DB. We will start it today for at least 45 minutes or so. And then tomorrow for half an hour, we should be able to wrap up because that we are not going to go too deep into this, but we will still be at least talking about how NoSQL DB works.
Hello.
Yes, Ram.
In AWS, did you write this code in Athena?
Sorry, you're saying in AWS where I write?
Did you write this code in Athena?
You can, Ramnath, you can do that.
So I have basically, if you ask me up, I have my own setup, which I have basically with a cluster. And I have not used any predefined build. It's simple EC machines, which I have taken up. And on that, I have set up my own, basically, this big data environment. I have customized it a lot based on my requirements. And that is something which I use. Means it's something which I have developed sometime to create a lot of quick prototypes for the customers and all that, so that I can show them up that quick prototype way how your problem solution will look like. So it's a simple some 6-node machine which I have just created, not very huge, because that cost I myself bear, and that's something I just run it there. So I have set up even Apache Hive and everything on top of that. So that's where I've done it. Okay, so I hope all of you are able to create the table by now because the code is available for you. Tell me the first problem solution. It's a very simple one. There's nothing complicated in the first part at least. Can I get the answer how you will hit your first problem solution?
What is the first statement, problem statement?
The first problem is find the total number of tickets for each year. So you have to say 2016, comma, let's say 10,000. 2017, comma, this number, like this. So if we have given 5 minutes to understand the data, then it's super easy.
So Shivank, we can do like select count on maybe summon number, and then we use over close and partition by year. I mean, we will use this date issue date column, and we will partition by only year using year function.
Okay, that sounds like a good idea. Number one. But which column you said you will be doing it? Summon column.
Yes, summon.
How you will be using the summon number uh, basically to think about the
No,
year?
no, no. Let me think a little more on this.
Take your time. But your first thought was right. I am happy to hear that you're thinking about using some partitions here. Anyone else? Yes, Manju, you want to say something? Okay, Arun, any thought? How you're going to solve it?
Shivang, sorry to interrupt. The file which was in Shivang's project is not there. Actually, someone moved that file. Can you just check it once?
No, what you're saying? Sorry, I couldn't hear you, Gaush.
That project file 1.5 GB file, that was not in the project file directly. Someone moved that. Can you just check it once?
Guys, don't do that. It takes a lot of time to upload it. Yeah, somebody removed it. I already asked all of you to create only external table. Okay, let me again. You can even go ahead and quickly download it if you want to. Like I said, come to this link, quickly come to this part. I'm anyway going to upload it meanwhile, but it will take time. So better to also have the data at your end. Come to here, click on export and click on CSV file. I'm just giving you this link. You can click on this link directly and go there. Okay, you can click this link anywhere, right? Go there and quickly download it. Meanwhile, let me just bring up this data. Yeah, that was my only worry, because if you keep in SDFS, somebody by mistake also move it here and there, it's gone. And it's not their mistake also. I'm just uploading, it will take its own sweet time.
should we use data?
I can't hear you, Karthik. We can't hear you at all.
Data
No,
and
even now. I think there's some internet issue, Karthik, at your end. Just can you take a quick look at it?
Party.
Karthik, can't hear you at all. Anybody else who want to speak out on this, how they will be approaching this up?
Shivan, can you just pop up the questions tab?
Mm-hmm. Karthik, maybe you can disconnect and again rejoin. That might help. Maybe just refresh your internet connection also once if required, maybe restart it or. Yeah, I think you both started talking together, Gaush. Can you say again?
Yeah, can you just show that questions?
The question is find the total number of tickets for each year. Then the second question is find the total number of states to which the car with ticket belongs to. The count of state is mandatory here, providing the exact if the state is optional. Let's first hit the first problem. And now the last 2 minutes, guys, to complete it. After that, I will show you the solution because we have to solve multiple problems today.
We can do like this: select a plate ID,
Mhm.
issue date, which is like 2007, and we want 2007.
Yeah,
Yes,
2016, 2017.
yes, 2016 and 2017. We have to like greater than or equal to 0101 like 2017 and 0101 ticket like 2017, and we can do group by.
No,
Like
there's
this.
no group.
And then we can partition the year.
No, there's no group by required. Yeah.
Okay, directly we can go for the partition.
They will be group by required. Yeah, you're right. Because of years, fine. But how you got 2016 and 17?
We have to check for the issue date which is greater than or equal to 2016, and then again we have to go for issue date which is less than 2016, and then we have to take year wise like that, 16 and 17. Between, we have to use the between operator.
Okay, makes sense. That's actually a good approach. Though you are not given a complete answer, but the logic wise you are completely right. Now let me show you how we will do. Guys, I need your attention now because since I said we have a hard stop at 8:45, so let's at least target to finish some problems, and then after that it will become your homework anyway. Now, first thing, before we start on anything, think about, right now I have not given you all the problems, but you have to always think about, can I optimize it? Now, I have only given you 2017 data, but when you are doing the data analysis for maybe the New York City police one, then you will be using the data for all the years, whatever they have published. It will become a big data. This 1 year data itself is a 2 GB file. Imagine all the years when we pull up, it will become very huge data for us. At that moment, it will be, if you will be just sort of trying to apply your Hive with a non-partition table, thinking about it, it may not be efficient. Yes, it could be possible that without partition, you can also work across. But you have to still think, what are the major queries you will be hitting? Now, looking at the first problem, it looks like, yes, we should do a partition with respect to year. Okay, which is fine, a good thought. When you will read the other problem statements, you will feel like we should do maybe a partition with respect to month, which will be even more helpful, which I have not yet reached to that point, but is going to be helpful. Now, another thing which everybody was missing, which I told you clearly yesterday, look at the file formats. Don't save it like a text file. Non-partition table, I saved it like a text file. Reason being because I wanted just a non-partition table, which I don't want to use it. I just want to maybe insert the data from this non-partition to partition. If I wanted to use this non-partition table for my further processing and query, I have to take care of a few things. For example, is my file format correct? Am I using ORC format here? Am I making sure that I'm using the proper compressions because my data set could be huge, right? So all those things, if I'm thinking well off on those aspects or not, is going to be important here. Okay. Now to start with, how we will be having this query. I will give you this code also in your Google Drive again. So keep that Google Drive open. Don't close it, please, because you will be requiring that as well. So first thing first, let me show you the table which we are going to create. Now, definitely you can do it on year basis, looking at the problem statement. But since, like I said, I will also be creating this table later with some lot of month processing query. That's the reason I have done it for the month side. Look at this. I just drop a table in case if it already exists. Further to that, look at all these commands. I'm just giving all the column names. I'm giving and creating the complete partition table with it. Let me just make them down so that we can read them all. Okay. Now see from here. Okay. Let me bring this also down. Okay, look at this now. So I have given all these columns. Again, it's an external table. I'm creating the partition by month. Like I said, if you feel that it should be based on the year, that's completely fine. I leave it to you to take this call. Now, is there any month column here in the table?
No, sure.
No, right?
No,
That's something you have to also keep in mind. But I created it based on month, right? We will see to this, how to fix this part. Now, notice I'm saying stored as ORC. That's very important, especially when you're working on big data Hive. That's the whole reason of bringing this Hive assignment and the project for you. You will be defining the location, define your table properties, and here you can define your compression as snappy. Okay. So basically, this will also ensure you want to compress the data across because maybe your data set is huge. Now, this part, I would still say you have to take a call, whether you really want to compress it or not. I also did that because I was using my own AWS cluster and I really don't want it to cost to be very high. So I also did that for the same reason. But this call you have to take. But definitely having the proper, basically writing part of it like ORC or Parquet or text file, that is really important to think of. Never ever do any query on the text file. If you're doing that, again, you're doing it the wrong way. Okay, it's not going to be optimal. Now, how we will be inserting the data? Now, here I clearly told you, if we have to insert the data, ensure that I have basically all these things set up with respect to month, because remember I'm doing the partition by month, and in the non-partition table, I don't have any month column. So how I'm going to handle this? So now ignore this properties anyway, we know about it. Even I should have said dynamic is equal to true, it's just that I didn't note it down here. Now I will say insert overwrite table. Partition is month. Notice how I'm inserting now. Take all my columns of my non-partition. I did it with an asterisk. And after that, what I'm doing, I want a month from it. So what I did, I wrote a sub str function to basically go to the seventh part of it, take the 4 after that. Similarly here also to get the month and concatenate it. Okay, because if you look at this issue date, see this issue date. This is basically telling you this, right? You have to definitely, this is a string. You need to take out the substring out of it so that you get the exact month or the year from it. So that is what we are doing in this case. You can go over this query in detail while executing it as well, like where it's 7 stopping and all that. I'm not going into it because you can do that. Now from your table, where your issue date like 2017, I'm using percent just to say that, okay, ignore whatever is there before it. But in case if I have 2017 in this particular issue date, then I'm fine. This data now belongs to 2017. Okay. This is just to show you if you still want like all the 2016 data, 2017 data, 2018 data, then this where clause was not required. Okay, this is just to show you how I wanted to go about it. Any particular reason for not keeping issue date as string data type? You can, so nobody's stopping you. I have intentionally done that here. Reason being because I wanted to show you some string sort of functions as well. But you're right, you can use even the data type as well. And further to that, you can go about it. One more reason why I have basically done in this way is look at here. Okay, look at this here. This is a date and time, right? So it's more easier if I would have taken it as a date and time. But like I said, I have seen people majorly doing these sort of mistakes. They get confused that, okay, if I have 2017, 2016, how I will pull this out? They don't think more often that, okay, if I have something like all these functions available with me using which I can very easily play around. For example, using the like function, using the concat and sub-str will be helpful. If you look at this, this was such a simple query to start with. But still, most of you, I think only 2 or 3 people were able to think in the right direction. All of you basically after even learning Apache Hive so well, still was struggling to even reach to this point. And that is the main thing which I wanted to bring. Okay, clear everyone till this point? We have not even started writing any query yet, but we have at least come to a stage to understand that how we will go about it to basically have a kickstart on this text. Now, second thing, how we will hit our first query to say that find the total number of tickets for each year. Again, now after looking at the insert, can you tell me what should be my query? Anybody? Now it's an easy job, right?
Count stars.
Yes. So here we can again use all these sub-str functions. We can say select sub-str issue date. I just pull out the last 4 because I need those years, starting from index number 7. And then I'm saying as year, and then I'm doing a count asterisk from this particular table, which I've just created as ORC, group by issue date, because I need again this with respect to my year. And I'm also doing an order by year so that I can have all these results in a sorted order. Clear everyone on the first problem statement? You can see before even I move to the first problem statement, I have to do so much of optimization also. Everyone clear? Any question on this first part?
We can use cast also, right?
You can use what?
Cast of issue date as date and then extract year.
Correct. That's completely fine. We can do that. So for writing the SQL query, you could have multiple ways, but whatever you said is also right.
Okay.
Okay. Now go ahead and solve the second problem.
Shivam, why not bucketing?
Why you need bucketing for this part? Means, yeah, I know I've not given you the other problem statements, but if you look at these 3 problems, then don't you think it will be easier? Because first of all, I know in my data set, I don't have like a lot many years, right? If I have to, let's say, do the partition with respect to years also, I don't have too many years, right? It is in my data set, I have only 2016 and 2017. But even if I take all the data set also, it will not be more than 30 years. 30 partitions seems to be reasonable, correct? If I have to create, it will be more faster for me to search in that case. That okay, all the 2017 is going into one partition. All the 2016 is going into one partition. If you would have said that, okay, I want to create 30 buckets. Don't you think in that case, it is highly possible that 2016 and 2017 could have fallen into one bucket? Right? Then the searching at that node level would have become tougher. That's the reason we are not thinking at the bucketing level. We are thinking at the partitioning level. If the number of partition goes huge, then only start thinking on the bucketing portion. Otherwise, you will have a mix of data on a single log.
Yeah, okay, got it.
Now, look at this problem and tell me the answer for this. This is more easier than the first one, actually.
So Abhishek, Shivang, can we do like count distinct registration state from the table? Then we will have all the states.
Awesome. This was exactly what I was looking for. So in this case, what you can do is you can come here and say select count of distinct registration state from your New York City. Let me do one thing, guys. I think I forgot to give you this code. Meanwhile, let me quickly give you this code in case if you want to also have this external table with yourself. Just allow me a minute. I have written down all the codes for you in that file. Okay, you can go ahead and copy it from there. Okay, all the
Yes,
code
we are able to see in that file.
So all the code whichever I'm going to use, I will keep on sending it there for you so that you don't have to struggle across to run all those things. Main thing is I want to ensure that you understand all this well. Okay, go to the third problem now, which states that some parking tickets don't have the address on them, which is a cause of concern. Find out the number of each tickets which have no address. That is the ticket which one of the street code, that is street code 1, street code 2, street code 3 is empty. Okay, very simple. You can easily do that. Think about it and give me this answer.
So is it null or is it empty, Shiva?
When I say empty, it was null. It means the same.
Okay, so we can use like null operator, that street code 1 or street code 2 or street code like null.
Everybody copied this code as well and executed it. I'm just giving you 2 minutes to kind of fix it and have this at least ready so that you can execute your code as well. Done? Okay, let me just show you the third code, which I think somebody have just rightly given it as well. But let me just show you this code as well. So you can do in this way. Select count asterisk from my this table where my street code is null, street code 2 is null, and your third street code 3 is also null. Right? It's pretty simple SQL query which we have got basically from this. Now let me give you some aggregate queries. I've already given you actually one or two, but let's start with a simple one. And I think your homework will have a tougher queries.
I think you missed out in the where clause.
Yeah, sorry. It should be out. Okay. Now, what I want as a next step is, I want the top 5 frequently occurring violation code. Means, let's say they want to make the public aware that, okay, these are the most violation we are noticing, and maybe based on that, they would like to tell to their public that take this or take that steps and so on. So that is for what they need an answer for it. So return the top 5 most frequently violation codes. Very simple. You should be able to do it in 2 minutes.
Distinct count.
Distinct count.
Violation, we have to use distinct, and count statement it will give the sum total.
Do you need
We
to
have to. Let me come back. Sorry.
I think Shivank, we have to group by with the violation code and then count. And then from that we'll remove the top 5 by ordering by default.
How you will get the top 5?
Order by DSC and top 5.
You will do an order by DESC.
Group by, then order by, then
Something we will use the
limit
rank.
as 5. Limit as 5 also we can.
Perfect. Now you came to the exact answers. All of you actually attempted very well. I just make it 5. Okay. So we can say select validation code count asterisk from your table, group by violation code, order by count asterisk DESC. Clear? Everyone, any question on this part?
No, Shivank.
Okay, let's go to the second question. How often does each vehicle body type get a parking ticket? And also tell me for the vehicle make also.
Shivank, I didn't hear the last part. Vehicle.
How often does each vehicle body type gets a parking ticket? How about the vehicle make also? Actually, this is super simple. After that, there is one more query, and then after that, the things will become complex, which will go as a homework for you.
Shivank, can you just elaborate this question, like how often?
Yeah,
Hello?
so basically, I have to get the vehicle body type. So for every vehicle body type, what's the basically how often they have got the parking ticket for it? It's again looks like a frequency, right?
Do you mean like the how many times? I mean frequency of,
Correct.
or you mean to say like in like 365 days how I mean kind of an average.
No. I am not restricting it with respect to time bound here. Means I just need a frequency.
We can use like SUVN equal to 100, SDN equal to 150 like this, we can give the parking tickets. Depends upon the vehicle body.
So what are the column names we're gonna use for it?
Vehicle body type and vehicle make.
Perfect. So this is your query case in front of you. So you can see this as well, that how you can actually hit this query. This is just returning 10 here, but you can make it 5. It will start returning 5 for you. Okay. So that is the way you can go ahead and execute it. In fact, let me now do one thing. Let me start giving you just the questions, just to show you what kind of questions are going to follow up after this. And you have to try this on your own later. Okay. So let me copy paste all the problem statements for you so that you can read it along with me. And just to give you the idea, these are the type of problems what they had given it to their data scientist teams when they were looking for it. Oh, what happened? It didn't come it nicely. Anyway, let me show it one by one then. So this is an easy one actually. The president is a police station that has a certain zone of a city under its command. You will find 2 further classifier of this president. One is the violating one. These are the ones where the violation have occurred. Second is the issuer one, which these are the one that issued the ticket. So you have to return the top 5 violating precedents and issue a precedent by frequency. Again, this is queries more related to your count aspect. Nothing special in it. Now let me show you the tricky ones. This is where you have to really think about. I think I gave some 5 problems which are tricky. Find the violation code frequency across the top 3% which have issued the highest number of tickets. Do this percent zone have the exceptionally high frequency of certain violation code? If yes, list them. This is tricky, I'm telling you beforehand itself. Think of it, and then only you will be able to come up with the answer. You have to use something called as issuer precedent that will help you out with this, but there will be, you also have to perform some join operations here. Now, how you will be doing the join with the same table, you need to think about it. I just gave you a hint. Means you will be doing a join with your own table. Okay, that's one thing which is trickier. Second thing is you will be still having some complex query written here on both the join side as well. So that's something you have to again think of to get to this answer. Again, like I said, it is a trickier problem. Think about it. And I will copy paste all these things in your Word file also. So nothing to write down at the moment. You can get all these things from your Word file as well. Similarly, let me show you another one. Find the frequency of parking violation across different times of the day. The violation time field is specified in a strange format, which you will see it in your data set. Find a way to make this into a time attribute that you can use to divide into group. Again, a little complicated problem. You have to think again on this part. This problem did not require any sort of join as such, but you need to be very good in playing with your date commands. Okay, so that's where this makes it little interesting, so that you have to think around on this part to get this response. Maybe I'm stopping here. I will give you maybe more questions on your Word file. You can try them out. Definitely some questions are really tricky to think about, when especially your last question which I created. It took me almost 20 minutes to think of the last question itself, and the SQL code which you will be writing for it will be close to 25 lines. Okay, SQL code of 25 lines is actually big. So you have to sort of think around, make it in a smaller queries, and then be able to hit that. So it's more related to the seasonality of the data and so on, which you need to really work around to get to this spot. So this assignment will take you a few hours to really spend time. So I'm not asking you to do it immediately. I will assume that you will at least do it by Monday and come back with it. We can again discuss on this. I will publish the solution as well, but definitely by Monday, I expect all of you to solve it. So try to divide your time every day by 1 hour each, and you should be able to think around to get every problems which you have got. At least now you are clear on the initial parts, that how you think about optimizing your data set before you hitting any query. That was the first step you understood. Second step was just to see that, okay, even if we are getting your data in the string format, you have functions to resolve them out. It's very simple functions what you have taken up after that. But once the things will become tricky, then you will start finding the usefulness of your optimizations as well. Because then when you perform all these joins and all that, you will notice that if you would have done it on a text file data, it would have ended up taking a lot of time for you. So the best thing was that we have done it with respect to optimization from the initial stage. Any question on this? Everyone clear? I'm giving you a minute. If you have any questions, please ask. Okay. Now, the next step is we are moving towards NoSQL DB. Yes, Ram, you were saying something?
No, go on.
So now we will move towards NoSQL DB. Hey, just one quick thing I just want to finish in 5 minutes. I will not spend more time, but I simply forget about it. There is a possibility sometimes when you're writing your Hive query, maybe you want to perform some operations on that. For example, let's say you say select, and maybe you have a column 1 from your table. Maybe you have this thing. And we have seen that, okay, if you say that, let's say upper, it will convert it to the uppercase and will help us achieving all this. It looks all good. Let's say I wanted to do some other type of operation. Maybe what I want is, let's say if in the file it is written as, let's say, Shivang. First, I just don't want it to get converted to upper. In fact, I wanted something like this. Shift, I want to just take the 4 characters, shift, and maybe I would also like to add maybe some numbers or maybe something like that. Means I want to do some operation, in short, which is not available as a part of any function. You cannot even use concat, you cannot even use all this substring to even resolve to that state. You want to do some very complex operation on this. So in that case, what we can do, because I don't have that function. So let's call that function as f. I don't have that function. How to go about it? In that case, what we can do is we have something called as UDF. What does UDF do for me? You can write a Java code. Okay, you can write a Java code to define your function f. Okay, definitely the Java code will be in the Hive style, not your normal Java code. You can write your Java code to write a function f, and then after that you can call this function f in your SQL code. Definitely you need to register that function and all that. That's a different thing. But this is also one important and very powerful thing in your Apache Hive. Very, very powerful. Because a lot of times we really do not know how to get these functions. In fact, I have written a lot of functions which are not supported by Hive. So there are many functions which I needed for running the Hive query, and I didn't have them up. They were like statistics functions, mathematical functions, depending on the client need, I've come across them. So in those cases, what I've done is I have written those UDF Java code, and those Java code I can just call it to get my results. Okay, so this
Based
yeah. Just hold on, let me just complete it. So this is full format called as user defined functions. Okay, user defined functions. So that way you will be able to kind of define your code within it, but keep in mind there are some rules to follow when you write this UDF code. It's not like you write a public static void main and can do with it. In fact, you have something called as evaluate functions and all that, which you have to write in this to kind of get this. Now, what I will do is maybe I will make one Java code available for you in your drive, so that in case if people who wanted to walk through it get an idea that how this is written. But since in this class we don't have much of the people who know Java background, I think just one or two knows it. That's the reason I had decided to move it out. But you should at least know about it, that okay, we have something like that available for us. And at the same time, like I will make it available in your Google Drive. So in case if you know Java or you are interested to still look at it, you can go through that. Yeah, somebody was asking a question.
me, I was asking if these are like creating custom filters.
Yeah, you can write any sort of functionality, any type of,
Okay.
just like whatever you can do with the normal Java, you can do it with here also. You can write something like in column 1, maybe you want to have some filtering or whatever. You can write anything. It will take the bulk of data and perform for you. Similar way, we also have something called as UDAF that works on a row by row basis. I'm not going into this. That also sort of is very helpful. Generally, I have not used too much of this user defined analytical function, but this is definitely a lot kind of used across. Yes, it will be only Java, I suppose.
So
Any
Shiva,
other
UDF, yeah. So UDF is being supported only by Java, is it?
Yeah, currently, yes, they have come up with some wrappers. I will not recommend you to use them at all. They are very, very slow. Means
Okay.
they are not official. It's just that people have made it available through their GitHub codes. You can go and set up them. And once you have that setting up, you can start using it with the Python code and all. But it's completely done after that.
Okay. Okay. I started my career in Java, so I'll try to explore a bit on this UDF.
Yeah, then you would love it, Girish. This is a very powerful. I have like almost, if you ask me, I've taken, let's say 10 projects per year in high. Then in that case, at least out of those 4 projects, I have to write UDF.
Oh, okay.
This is that much. Means a lot of times you can have like hacks that you can use to get to the results. But instead of using the hacks, better to write UDF. That's what I prefer. And UDF also makes the query time very fast. Very, very fast. You will find that you hit it, immediate you get a response. Because it don't have to go through that map reduce things and all that.
Oh, okay. Okay.
So even for performance perspective, it's pretty good. And basically, like I said, if you see 40% of the projects I'm using, let's say per year on this, it's definitely something which you should look at if you are good in Java, guys.
Okay.
Okay. Any question on this, guys? Before I move on down to NoSQL DB. Okay. Let's talk about NoSQL DB. What is this? What are the things we will go about it? What are the challenges with it? So today I will just kind of give you a high level insight on this. Tomorrow, maybe I will go to a little bit on HBase and will show you that how my HBase works. Maybe I will show you some snippet of code also around it. We will not take a very deep dive into it. Like I said, it's just an introduction, though it can be a course within itself. But I will give you a high level idea how NoSQL DB looks like and why we need it in fact. If you look at the SQL DB, what happens in SQL DB? You have a very clear picture of row and column, right? You can write it up. It works really great. In fact, if you, let's say, have a table in your production system which have a lot of columns, let's say C1, C2, C3, maybe you have some hundreds or thousands of columns in your data set. Okay, let's say some 500 columns. Now, your data set is spanning for millions of records. It's pretty huge. Okay, billions of records. And it's running in production very well. Everything is very silently sitting up and you're very happy with it. Suddenly, because of some client needs, you felt the need of adding maybe a new column to this data. Okay, so you wanted to add a new column. Now you will go to your database administrator, will ask them that, hey, I have this new column addition requirement and I would like to add it. His response will not be good. If you ever interact in fact with your database admin for asking this sort of things, because he will not be happy at all. He will say that no addition of a column can introduce a lot of bugs. Maybe the current system could come down because there could be a lot of constraints in that table. The data set is huge and it could introduce many new issues around. So he will not be happy to do any changes for you in that case. Now, it looks okay. Maybe you convince him because of business requirement, explaining him that, yes, this is something we need and we want to ensure that this column is required for the company good. Maybe he added it for you. And let's say that that column is C501. Okay, fine. You started working. Next time you reach out to him again because you felt I need another 1 or 2 columns, he will kick you out. It will be a very tricky task for him to keep doing that because it's going to be a headache for him if something goes wrong in this case. This was one of the major problems in your RDBMS data sets when they are running in production. The example which I gave you have exactly happened in front of my eyes so many times when you're working with RDBMS systems. That it's running in production, you keep on fighting with them, and it's very difficult that you have to add something or remove something from the existing one which is running in a production side. Second problem. Let's say somebody opened a startup. Okay, maybe a client came up and said that, hey, I have a startup. Let's say e-commerce. It's an e-commerce business. Now, in this e-commerce, think of it like Flipkart. Flipkart, when they started only with books. I hope all of you can recall that. They started with just books selling. Slowly, they have started adding the other items and moved on with the other things. Even if you take an example of Snapdeal, if you recall, they earlier used to just sell some coupons and deals, not everything out, but now they added everything. So when they were selling books, in books you could have some column, right? Maybe it could have like book ID, there will be author name, number of pages in that book, right? The published year, and so on. Maybe you have thought about like this. Now, what happened here? As soon as you thought about these books, maybe you thought that your business started doing well, and slowly you started introducing some electronic item, let's say like TV. Okay. Now, this TV will also have ID, but will it have author name? No. It have different attributes. Maybe it have size. It have what is the type of screen? Type of screen, right? So all these things like model number and all that. So a lot of things will be with respect to TV now. Notice the difference in the columns here. Now imagine if you were actually inserting all this data into an RDBMS table. What would have been the challenge in this case? The challenge would be that in this case, when you create a columns, in your RDBMS, you have to have one ID column then. Second column will be your author name. Third column will be, let's say, number of pages. Fourth column will be, let's say, published year. Fifth column will be, let's say, size of the TV. Then after that, type of screen. So type of screen. Then after that, maybe a model number, right? Like this, you will have some columns here. Now, if you look at this, when I will insert the data for books, It will be like, okay, for ID, let's say you inserted one, author name you inserted something, pages you inserted something, publish here you inserted something. Okay, you inserted something here. Then the size will be blank, it will be null data. Type of string will be null data. Model number will be null data for the books part. For TV, these author names, pages, publish here will be null data, and the remaining you will be filling up like a data item. Now in RDBMS, if you think about it, even the null eats up some space for you. It is not like that you are inserting something and null will not eat up space. That also eats up space. And remember, I took this example only with 2 items right now. Imagine the number of items these e-commerce have. I think there are millions of items. And every item have something or the other unique about it. It could have different category. It could have so many other columns coming up. So in that case, RDBMS will not be able to scale up that well. That was a big challenge when it came up to your Hadoop, with respect to your RDBMS systems. And those RDBMS systems basically started having all the problems. I'm just bringing it here so that, yeah. Now, so that you guys can also read all the stats directly. Sometimes the question comes like this. Now, so basically that was the biggest challenge what we face across with this SQL side of the systems as well. Now, how we go about it? Okay, fine. We will be thinking about some other solution, which I will be showing it to you that how we will proceed with this. But for now, everyone clear on the problem side of it? What are the drawbacks what we have with it? With the RDBMS side? Okay. Second big problem was the size of the data. As we know, in RDBMS system, fine, maybe till 6 terabytes, some 16 terabytes, I should say, it's still okay. But after that, it's a challenge. You can still come back and say that, hey, I know in RDBMS also you can create master slave sort of architecture. That's allowed. Yes, you're right. But if you know how this architecture works, you will only be writing everything in your master node. And on the slave node, you perform the reading things. You perform all the reading on your slave nodes. And when the data is written to the master, it kind of go and replicate in all the slave nodes. And then only the reading happens. It's not a good way, right? We have already learned about Hadoop, which can help us to solve this problem. So even the data size could be a big issue around it. Then why can't we be okay with just Hadoop systems? We have just learned about Hadoop systems. That should also be fine, right? Why, okay, if RDBMS is not working, why not MapReduce? Why not Apache Spark? Let's keep Apache Spark aside. We will talk about that later. But why, let's say, not MapReduce? The problem is in MapReduce, if you want a random lookup of your data, then it's a challenge. We are already well aware of it, right? Random lookup of the data is the problem when basically we talk about Hadoop systems. Secondly, the writing part, like if you want to go and write, change something in your data, it's not visible. But when you're working with respect to this data set, maybe I need to do some updations. I need to keep on writing row by row also. How I will be doing all that as well then. That will also become a problem. That's the reason we have to think about another solution like a NoSQL DB, which will be using across to solve this. That's the reason these MapReduce systems and all will not be able to help you with that. Definitely NoSQL DB will have most of the advantages coming from the Hadoop. Like for example, it is highly scalable. You can keep adding a number of nodes, which was not possible with your RDBMS systems. With respect to the volume of data, it's very easy now to cope up with that. You don't need to have a fixed schema, which I just explained you that that in your RDBMS, you had this clear problem that you have to create all the columns and go about it, right? So those were like really a big issue when we have to do. Secondly, do not rely on the MapReduce programming. So there is no MapReduce programming as such here. It have its own way, own query engine to work across. We will see to them, but that is what is going to be. Any questions till here? Okay, now one more thing. Just to give you an example of schema change also, like when I say schema change, what happens basically, like you have, let's say, one column, which is, let's say, initially of integer type, later you want to change it to character type, or vice versa. If you want to change your schema type, then also it's a problem. Let me give you a live example. In 2014, YouTube faced this problem. In 2014, they were basically, YouTube was using MySQL for storing all the video related information. Okay? Now, basically, they used to store something like number of likes, dislike, views, and all of that. What they had was, they had one column in that table, which was 32-bit size integer. Okay, that was one of the columns they had, and basically they were storing the number of likes in that, because they thought that, okay, number of likes will never be reaching beyond some range, and basically they were storing in that particular table itself. Then there was a song which came up called as Gangnam Style. How many of you recall this song? Anyone?
Yes, it
Yes,
broke
yes.
the
Yeah.
records of highest views.
It came in 2012, but it broke this counter in 2014. If you recall, that song became so famous that it was in everyone's mind at that point of time. And what happened after that? They have to change their schema from 32-bit to 64-bit integer later on. This became a big news, actually, big news. It broke up YouTube completely, and they never even thought about it beforehand, that how to go about it. They gave no thought process around this. Clear, everyone? First of all, that why schema, I just gave you that live example right away to tell you that what kind of real challenges can come in. Okay. Now, before I even go and explain you how your NoSQL DB works, there is a very important concept which you should be aware of. This is called as capture. So what is this capture? Let's understand that. There are three important things which you should be aware of. One is called as consistency. What do you mean by consistency? So consistency, you can think of it like, I have written my data at one side. Immediately that data should be available on the other machine also. Okay. So that is basically called as consistency problem. So what I'm doing here is that I have a data which, because I'm working in a distributed system, right? So maybe you have written a data on one data node, or maybe you have done a changes into one data node, because now with NoSQL DB, you can do changes also in your records. We will see to that how it works, but you can do changes. In SDFS, we were not able to do changes, but here we will be able to update my data also. So let's say you have done some update in one of the system, in one of the data node, immediately that data should be reflected on the other side as well. There should be no change in that. That's one of the important thing called as consistency. Second thing is called as availability, which means that if my basically system is there, so whenever you do a request to your system, it should always be available. Okay. Now, it doesn't mean that I always get a consistent output. Means it could be possible that I'm getting older data, which is completely fine with me, but I want my system to be always available with no downtime in that case. That is called as availability. Third thing, which is called as partition tolerance. Partition tolerance. So here, your system continue to function and it will be able to work. Doesn't matter even you have network partition. What I mean by that, as you can again recall from the architecture of Hadoop, even if your data is sitting into different machines, it should still continue to work across with them. Now, what happens basically in the capture? Your SQL, if you look at it, your RDBMS systems, since we don't have like partitions sort of thing there, we don't have all those different data nodes concept across with it. So it follows your consistency and availability both, right? This is your RDBMS system. It works really well for the consistency. Whenever you write, immediately you see the other output. Even it will always be available for you. It will be all good with respect to it. But what CAP theorem states that along with partition tolerance, you can only be able to have any one of these properties. Either with partition tolerance, means when you're working on a distributed system, either you can have a consistency completely or you can have an availability completely. But all three of this together is not feasible at all. So all your NoSQL DB have to follow this CAP theorem along with that. Now to give you some examples, so consistency, if I talk about consistency and partition tolerance, if I talk about, this is being used by your, means basically used in your HBase. Okay, in HBase basically we use this, and even in MongoDB. I will talk about a bit on this, so don't worry about that. So this is basically used like this. Similarly, if I talk about availability and partition tolerance, this is being used in databases like Cassandra and DynamoDB. Okay, so again, something to keep in mind that you will have a consistency and partition tolerance, and then you have availability and partition tolerance defined in these NoSQL DBs. Now, to give you an example, basically to see how this whole thing looks like, everybody of you must have used WhatsApp, right? In your WhatsApp, when you send a message, have you noticed that sometimes even if you have two different maybe mobile in your own house and internet is working across, have you noticed you send a message, it sometimes only shows you one tick, means it have not yet reached to the other side at all, even though the internet is working. Have you seen this situation? Sometimes it happens.
Yeah.
It will show
Yes.
you one tick. This means the system is not available for some time. It is ensuring, WhatsApp is ensuring that you receive the consistent data. It should not happen that you receive some junk data or some whatever, but your data should be consistent. Whenever the network will become available at that time, you will receive it. Because maybe intermediately behind the scene, when your message is getting passed through, maybe the network is not available for that. So that is a very good example of WhatsApp ensuring the consistency. Okay. In fact, WhatsApp initially started with HBase. Later, they have also started using MongoDB and all, but that's what they were doing as well. Talking about availability and partition tolerance, you must have seen if you go to these flight, like when you go to any shopping site or maybe even the flight booking across all that, if you have noticed, a lot of times when you go and see the prices, or maybe even if you look at these hotel pricings and all that, it will show you maybe old price. It will show you the old pricing itself. Maybe the data is not yet updated for them. But when you try to book it, then have you seen this error coming up? Hey, looks like the pricing have increased. You must have all come across these scenarios. Oops, looks like the price have increased for the ticket you're trying to book. That denotes your availability part. The system, they're ensuring that it is always available. It is at least showing you up that, okay, this is available. These are the hotels available nearby you. These are the flights available nearby you. Though the data is not consistent, even though they have changed it, the data is not consistent. They're okay with that. But basically, they are ensuring the availability for you. So depending on your business problem, you need to take a call that what kind of NoSQL DB you want to go for. If you want a very high available system, my recommendation is to think about Always Cassandra. This is well versed used in the market. This is sort of became a very popular ecosystem, and you will find it quite often getting used across it. If I talk about consistency part, MongoDB and HBase both are sort of easier. MongoDB is, I would say, more easier to learn because MongoDB just use the document store. I will tell you what is that, but it sort of just keep your data in a very simple format, and the queries are very simple to kind of also understand. It's more like just a JSON document, what you kind of go with it. On the other hand, Cassandra is even much more easier to understand. Why? Because Cassandra uses the SQL syntax, simple SQL syntax, just like how you say create table T1 and all that. Same thing you can do with your Cassandra as well. But on the other hand, when I talk about HBase, the queries are little tricky. Means it's not tough, I would say, but still the syntax is little bad. For a beginner, definitely sometimes it sort of runs on your mind. You think about it that, okay, it's a challenging part. But other than that, you're free to use any of these NoSQL DB at any point of time, which is completely fine. But you have to definitely keep this CAP theorem in mind. This is very, very important. Take a look closely on your business problem and see whether basically what makes sense for you at this particular point, whether I should be basically going across with respect to my availability or consistency or whatever, right? That's something you have to definitely keep in mind. Now, let me ask you a question. Tell me which basically if this is going to be consistent or availability. Okay, I'm just basically asking you questions here. Basically, it's going to be consistent or over availability. Let's say if I ask you what is going to be that. So if I ask you, let's say a customer bank account details, which includes the latest transaction, which one it is? It should be consistent or it should be available?
It should be consistent.
Why?
Consistent.
It is related to financial transactions, right?
Sure. What about notifications on your Facebook account or Insta accounts? What about them?
Availability.
Why?
Because as a user, I would want all my notifications to keep popping up.
Yes. Even if it's a little, in fact, have you seen that a lot of times, even the message have reached out to you, notification don't come. I have seen that lot many times. We don't receive notification. It comes like after when I have read my message. So that's something you have to think about in terms of availability. That's something you have to keep all these things in mind while working on it. So just always keep a watch with respect to the systems or the business case you are developing, and you will be all good with respect to understanding how this whole thing works. Any question till this point? Any question, guys? Whatever we have discussed till now? Okay. Now, let me explain you. There is another important concept within your even HBase, or even that will also follow up with other NoSQL DB as well. There is something called as column family. Now, what is this? So when I say column family, just like you have tables in your data, similarly, here in your NoSQL DB also we can have tables or data. Now, what exactly I mean by that? So generally, what is the way we used to keep the data in my SQL DB? I used to say, okay, I have an ID column. Maybe I have a personal data column, right? I have maybe professional data column. Maybe something like that. Or maybe I have basically something like in this, instead of personal data, maybe I have maybe a name column here, right? Which is basically sort of going to act like a foreign key. Here also I have, let's say, department ID or something. Department. Okay, so something like that. Now maybe what will happen, you will have another table. That table will be like a personal name table. So there will be personal name table, which will have, let's say, name, and your city, let's say, or maybe some more details after that. Maybe you have another table, which is, let's say, professional data. And then what you will do in this, you will keep like, let's say, your department ID, comma, maybe your department name, right? Something like this. This is the way we generally keep the data in my SQL. And then we will have all this like, okay, there will be the join with this name here, then department ID with this one, right? So that way you will be able to create all this, and this is called as normalization in my SQL. So you have to do joins to get all these records. On the other hand, in NoSQL DB, we prefer not to perform the join operations at all, because we know that any movement of data is an expensive operation. So we don't prefer that. We in fact prefer a denormalization. And in order to handle that, we have this concept called as column family. What does column family do for me? Column family, what it do for me is that within this same data set, I will create sub columns within it. Means I will embed the whole data into one. How I will do that? Now look at the change. I will say ID, comma. Now I will have this personal data as my column family. Now inside this personal data column family, I will have two columns inside it. One is going to be name and one is going to be city. Okay, so sort of creating a sub table within a table, and that is what I call it as column family. Means having multiple columns within a column which are related to each other. Now similar way, I can have another column family which I can call it as professional one, professional data, and here I will say my department ID, and then I will say department name. So these two columns will be within that. So all this information will be sitting in one table itself. It is not going to be that we are going to make it like a normal, like in SQL DB creating different tables. We will not do that. We will keep all this data within the same data set itself. That is what is called as column family. So personal data is one column family, professional data is another column family, inside which we have multiple data set as our need. Clear everyone on this first part?
What about
Yeah.
ID, Shivank?
ID will also be column family only. Just that in the ID itself, I have just one column which is ID. That's it. Yes, somebody else was asking question as well. I think two people started asking together.
No, I just told yes.
Okay. Now there is one more thing, guys, within that. So whenever I'm going to store all this data, the way it works is, so every column family will be having like columns inside it. So you will have multiple columns inside this. And every multiple columns could have, means every column could have multiple versions inside that. Okay. Multiple versions. What I mean by that? So one column family could have, let's say, 3 columns. Now if I pick up any one of the column, it could have multiple versions. What I mean by that? Keep in mind, even when you're working on your HBase, you're still working on top of HDFS, number one. Now, when you're working on HDFS, how you will update your data? That's a very natural question which will come. How you will update your data in that case? So the way it works is with the help of versioning. What do you mean by versioning here? So when I say versioning, so let's say you have a data right now which you inserted for a column, let's say for name. Okay, you inserted some data and the data is, let's say, called as shift. Okay, let's say this is the data which I inserted right now. So when it inserted data, it also inserted along with a timestamp. It also insert with a timestamp along with it. Now, next time you said that, hey, I want to update you. What is the command for it? We have not yet run. I'm just explaining you the concept right now. I want to update this record shift. So maybe I want to update it now to Shivang. Okay, this time I renamed it. Now what will happen? it will not go and delete this at all. Okay, it will not go and delete this at all. Instead, what it will do, for the same row, it will go and update it to Schema with a new timestamp TS1. Okay, now what's going to happen? When the request will come to read it, then in that case, it will say, okay, looks like in this particular row, I have two values. So I will return you with the latest timestamp. So by default, it will always return you with the latest timestamp. But if you want to read the older version also, you can do that. How we can do that, we will see to it. But you can also read the older version data as well, because it do not go and delete something which is there, because its row level deletion is not feasible. Even when you delete it, it just put a marker for it. Okay, it got deleted. So that when you go and try to read it, it will not let you basically read that record. But at the same time, just what it is doing right now is that it's adding a timestamp to help you to store the new record or to update something for you. It's a smart approach what they just came up with, and that is what we call it as different versions. This is version 1, this is version 2. Clear everyone on this part? How it will look like and all, I will show you this all tomorrow. But you should be very clear on this part, that how this overall system sort of looks like, means at least internally how these things work. You should be very clear that, okay, since I'm doing all this operation in SDFS, how we are able to still be able to do this update operations and so on. Clear everyone? Any questions? Okay, perfect. So let's connect tomorrow. So tomorrow class is going to be at basically going to be at 11, right? Now, one thing is the way we have decided, instead of increasing the time frame by 30 minutes on a single day, we will make it 15 minutes extra for both the classes. Okay, so that you do not get overburdened. We can take a call. Maybe we can add up those 15 minutes during the lunch break, or we can extend it to 4:15, which we will be ending the session, which we can see tomorrow itself. So we still have to talk for more 45 minutes or so to HBase, and then we will be moving to our Apache Spark. Okay, so 30 to 45 minutes is what I need to talk about it, just to give you a quick overview how NoSQL DB looks like. What is HBase? Even I will talk a bit on Cassandra so that you get an insight how this is different. We understood already about Capturum and so on. So tomorrow we will be understanding in detail some more questions on HBase, and I will show you some code, and let's move to the most interesting awaiting topic for us, which is the Apache Spark. Okay, and I will post all these questions of the project for you so that you can start practicing it up as well. Any questions before we sign up for the day?
Shivang, there's a small thing. Actually, yesterday they uploaded the class 6, but they uploaded the class 5 again as class 6 in the forum. Like the two, class 5 and class 6 are having the same video.
Okay, Lakshmi, can you take care of it? Here. Okay, I will inform her in case she is not here. I will, because she is doing all this. So
okay.
She
just wanted to let you know. So that.
Yeah, good you inform me. I will just inform her. Basically, even from her side also, that she have a team who is doing all this. So I will check with her.
Thank you.
Yeah. Any other question from anyone?
Can you upload these notes?
This notes? Okay. I can.
Miss all this 2 days.
This part you're asking? For the most. One second. Let me do it right away, so that I don't forget it. Generally, after that, I get busy into a lot of meetings, and I find it really tough to get time. So for now, I just updated it in the same project folder below. If you can just go through it and copy paste at your end.
And also the questions.
Questions I will update. I will leave it.
Okay. Okay.
Okay, sure. Anything else which we have to discuss, or any questions from anyone?
No, Shivank, we are good.
Perfect. Then we are good. Let's connect again tomorrow at 11. And we will be discussing in the starting about HBase followed by Apache. Okay,
Yeah.
thank you.
Thank you.